All right. So let's go back to where we were. We were working on a problem Friday, discussing how to work backwards from these carbonyl addition products. So we know that when we add a Grignard or an aldehyde to a Grignard to an aldehyde or a ketone, we get an alcohol. We know that if we add a Grignard to or two moles of Grignard to an ester, we get an alcohol. So but we can also take those product alcohols and work backwards. Even if we don't know what Grignard we added, we can come up with a synthesis uh, for the alcohol itself. So let's look at, we looked at C. Let's look at D. I'm just gonna cut it and put it on a blank sheet. So again, this is my alcohol, and it's asking me for 3 different ways I can make this, right? I need 3 different people to tell me a way that you will make this. Just give me one way that we can make it. We know it's an alcohol. We know from the instructions in the problem that the alcohol is a result of the addition of a Grignard. So we know all of that. So what 3, basically, I guess what I'm saying is what 3 Grignards could we add to a aldehyde, or in this case, a ketone? It's a tertiary alcohol. Anytime you have a tertiary alcohol as the product, that means you started with a ketone. So a ketone plus a Grignard. Anytime you have a tertiary product. All right. So what would you do?
Would you remove the hydrogen from the alcohol first?
Mm-mm. We're not asking about that part yet.
Oh.
I'm asking it's asking for 3 different ways that you can make this. So what one way would you use? We know we're gonna have a ketone. What Grignard or which one of these substituents would you use as a Grignard? That's what I'm trying to get at.
Could you use the aromatic ring?
Yes. Yes, you could. You could take the ring. Right, and this could be a Grignard added to a ketone. What else? Somebody else. This is a CH3, by the way. All right.
And could you use like that long alkyl chain on the left?
Yes. Right here.
Use a.
Yeah, you could add this in. I agree with that. And so the third way is by a process of elimination, you can add this methyl group in. The question is, how would you get these 3? That's the question. So let's start with the aromatic, because they're all going to come from the same intermediate. So let's do this. So this is CH3. This is OH. I'm just going to say, I'm going to go ahead and make this into the intermediate. O minus MgBr, and then this is the aromatic ring. All right. So if we started with the aromatic ring, and we're going to make this into our Grignard. All right, what do we need to do from this point right here?
What you do is addition, right? To form the pipeline between the
elimination.
Elimination to do the form the pipeline between the carbon and the oxygen, and then break that bond between the carbon on the ring and the other carbon, the central.
Right. So anytime this whole process going from the intermediate to the two pieces that came together to make it will be an elimination. So you put the pi bond back in, and then you kick off the aromatic ring. So you'll be left with this ketone. Plus this Grignard, which came from this. Right. So that when you eliminate that aromatic ring, it will end up as an anion like that. So that's where I'm going to put my magnesium, wherever that negative charge is. All right. So that's one way. All right. Let's see if we can figure out what a second route would be. Same intermediate.
Would you do the same thing, but just with one of the other Grignards? Like,
so let's take the methyl group here. All right, so it will be the same arrows. Can I put the same arrows in here, or should I just draw another intermediate? Let's go ahead and get that out of the way, because I don't want anybody to be confused about what's going on.
You can draw it.
So just put another set. I'll just change the color. How about that? So this arrow is going to stay the same. I'm going to reform that pi bond, and then I'm going to kick off the methyl group. All right. So then I'll be left with a ketone that looks like this. I'll just leave it in red. Plus CH3MgBr, right? Because that CH3, when I kick it off, is going to look like this. Right. So that's my Grignard. That's what will be my Grignard. And the other piece would be the ketone that I added. All right. And then if I did the final piece, let's just look at that real quick. All right, we're going to change the arrow colors. So let me not do that. So I do this, and then this. All right. Then that's good. That should give me what? What would that ketone look like? And then what would the Grignard be?
It would be a double bond on the oxygen, and then the alkyl group will go off to the side.
So would it be like this? What's the other part on that ketone? That's what I'm trying to get at. Because if I'm kicking off the alkyl group here, what's left on that ketone?
The methyl group.
The methyl group, good. So it's that plus, I think there was 3 carbons. Right, and that Grignard would come from this. All right. So when you have a problem like that, where it asks you to give 3 different sets of start material, what you're looking for in this particular case, you have 3 substituents on that tertiary alcohol. Each one of those, if you don't have a Grignard given to you, any one of those can be a Grignard, any one of them. So this would be an aerial Grignard. And then the other 2 will both be alkyl. Right, alkyl because of what's attached, what's bonded to the metal. Right, just simple alkyl groups. And the aryl Grignard is the same. There's an aromatic ring attached to, bonded to magnesium. There's a carbon in that ring bonded to magnesium, and so that's what that will be considered what we call an aryl Grignard. All right, let's do. Let's see. We've done C. Let's do A. So let me copy that. But so A asks for the same thing. It asks you to make this alcohol. You can see right away that it's a tertiary alcohol. So that means what? What's my start material? What would my start materials be?
Ketone and a Grignard.
Say that again. I heard the Grignard part.
A ketone and a Grignard?
Yes. It'll be a Grignard plus a ketone. If it's a secondary alcohol as the product, then it'll be a Grignard plus an aldehyde. All right. So where are my 3 potential Grignard reagents on this ketone or on this alcohol?
It's the 2 methyl groups.
Okay.
And then the alkyl chain.
Here, and here.
Yeah.
All right. I agree with that. So when you think about this particular intermediate, what it would look like, right? It should look like something like this. We'll just use BR again. Right, so we can do this. Right, this can decompose basically 3 different ways. Right. Somebody put the arrows in to show how we would knock off. Let me just give these different colors. How we would take off the purple CH3. What would the mechanism be to get to the 2 start materials there?
Can I try it?
Go ahead.
Okay. Is that right?
Yes.
Okay. Oh. Maybe like that, and then the other one like this.
Okay. Okay. I'm with you. So that's your ketone. All right. And then the granule would be just here, right? Is that right?
Mm-hmm.
So it'll be this. That's my ketone plus that. And we know that that granule will come from here. All right. Can somebody else try this group right here, removing that group?
I can try it, but I can't like draw on the screen.
Okay. Tell me what you would do.
You would take one of the lone pairs and form a bond with oxygen, but would the arrows go like up underneath that methyl group that we just took off?
So you want an arrow like that to put the pi bond in?
Yes.
And then we want to put in. So we're trying to remove this group over here, right here. So that's a 2-carbon chain.
Okay, so would the arrow go like up under the
Like that? Is that what you're saying? Because the
I was talking
electrons
about
are going to go to the carbon here, right? There's 2 carbons in this bond. There's a carbon that's in the carbonyl, well, that's in the alcohol, the intermediate, and then there's this carbon right here. So that's the bond that we're breaking.
so you take that. So you start at that pink dot that you just made on the carbon bond. And then you break that off?
Yes. Because I'm breaking this bond right here, right? The bond between these two. So that's where my electrons are going to come from.
Okay.
So then the ketone I get from that is just going to look like this with the 2 CH3 groups on it. And there's pink. And that's going to be plus and the CH3, CH2, Mg, Br. I could also write that like this. Same thing, right? Because it's 2 carbons in that chain. Right, either way. But the granule itself is going to come from the loss of this group. Come on, Russell. All right. And the third way, and it will be identical to the first, right? So it'll be same as the first route. Right? Did that answer your question? I think you seem kind of unsure about which bond to break.
Yes, sir. I answered it.
All right. Let me do this. Let's do let's do E and B. I want y'all to do these on your own though. So I'm gonna break y'all out into groups. How many people we got? 20 people. So go ahead and write those down, and then
Which ones did you want us to do?
the ones I have highlighted in pink are E and B. So write those down. And for B, let's just do, because one of the ways is going to be redundant. So we'll just do two ways to synthesize B. And then we'll do instead of 2 ways here, we'll do 1. Right? Because all 3 methods are going to be redundant. So let's do that. Let's take about 6 minutes and do that. So I'm opening up the breakout rooms now. And we need 1 person from each room to represent that room.
Hey, can you scroll back over to the other one right quick?
Oh, yeah. Can you see it now?
Yes, sir.
All right. If you're still in the main room, you need to join your waiting room. If not, I'm putting you in the I'm not waiting room, breakout room. If not, I'm putting you in the waiting room. So you need to go ahead and join your waiting room, your breakout room. All right. You should be in one now. Okay.
Uh,
Go ahead.
Here's what I did. So I did elimination, right? Okay. So I broke off one of the aromatic rings, and then for the Grignard, I got this. This is what I got.
Okay.
And it came from this.
Okay. All right.
Is that right? Or
yes.
No. Okay.
It's no different than the ones we were doing. It's just the Grignard is going to be different. That's it.
Okay.
So yeah, that's good.
Okay.
All right. Somebody go ahead.
For this one, for the first part, the first method, I broke off one of the alkyl chains. And I got, this is the Grignard that I got right here.
Okay.
And then for the second one, I broke off the methyl group, and this is what I got for the Grignard.
Okay. All right, cool. Both of those methods are sufficient. All right, somebody from group 2, Drew, Aaron, or Edward. Doesn't matter who shares. All right. Let's all be indisposed. Group 4, either Annalise, Lawrence, Taj, or Tamia.
Oh, I'll share mine.
All right, come on with it. Okay. All right. So you did, okay, you eliminated, and let me see what the Grignard looks like. You might have to, okay, great, excellent. All right, and then what did you do? Let me see the other one as well. Okay, and then yes, all right, good, good. Okay, 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 okay. It's good. That's good. Thank you for sharing that. Who do we have in group room 5? Caleb, Cecilia, Felicia, or Maya. It doesn't matter who shares screen. And when I break y'all out into breakout rooms, I'm expecting y'all to collaborate, not mute and take a break. So, or go eat breakfast or whatever. That's the whole purpose of doing the breakout rooms, is to get y'all collab. Because normally, if we were on ground, you'd be working through this at your desk in a group. That's why the videos come first, and then you come in and we have a discussion. Go ahead, Felicia.
I was actually confused on part B.
Okay. You want to share your screen? We can discuss it.
So can you see this one?
Yes, I see E.
So there's that one.
Okay.
But I got stuck, and so I didn't know what to do for like the second one.
So the second one, do you see the methyl group hanging off of that?
Mm-hmm.
So you can knock that off for the second method. Because if you notice, that ketone has 2 ethyl groups, or two carbon chains, and then it's got a methyl group attached. So you can knock off the methyl group itself, and then that'll be your second route. The first one looks good.
Okay.
Yeah, and then for the second one, you knocked off, I saw that you took off one of the ethyl groups, which is good. The other one, you can just take the methyl group off. Same process though. Start at the intermediate and then eliminate. Because when you don't know what Grignard you started with, everything is fair game. Everything that's there, that's attached to that carbon where your alcohol is fair game. Any one of those groups can be eliminated and become your Grignard reagent.
I'm still not seeing how to draw it though.
All right, let me share my screen back, and then I'll show you. It's coming up, and then we'll close out with this. So we're looking at B, right? So this is a CH3 right here. So the intermediate, I'm just gonna, I'll just redraw it. So it's O minus, and I'll just say MgBr, and I'll just eliminate here like that. So then what I'll end up with is this ketone plus CH3 minus, sorry about that, which I could also write as CH3 MgBr. So it's this other group right here that can come off. Uh-oh, not pink, not pink. Right, so you have a choice. You can knock off, you can eliminate the methyl or either one of these groups over here. And that'll give you your 2 ways to make that.
Okay, thank you.
Mm-hmm. All right, we're gonna stop there. On Wednesday, we're gonna start substitution, and I think I'm just gonna go ahead and leave the exam for Wednesday, rather than try to cram in substitution and then take a test Friday where we have to end up putting substitution on 2 different exams. I don't want to do that. So we'll stop here. We'll take a test on Wednesday. I'll post it Wednesday after class, and then you'll have until Friday to complete it. And then you can turn in this organometallics handout. You can turn this in the link that's provided in the organometallics folder. All right, we're gonna stop here. We'll pick up